Assalamualaikum and hello everyone. Welcome to the video for 2.1 Bohr's atomic model. In this video, we will be discussing the examples which I have set as your homework last week. Based on the Google Form feedback, most of you asked for me to discuss the example 10 as well as explain more about the energy level diagram and the line spectrum. So without further ado, let us look for our example 10 on page 9. Okay, so let's have a look here. So, for example number 10, here it mentioned that the spectral series below is found in the ultraviolet region. Okay, usually yang Miss ajar kamu mostly yang layman balik pasar beraputus kan. Okay, so most of the question memang terus pada situlah. Terus layman series ke, bracket series ke, fun series and so on. Okay, but if the question wants to trick you a bit, they ask you based on the region itself. Okay, remember here, the Lyman series will be on the ultraviolet region. The Balmer series will be in the visible region, whereas the Paschen, bracket and far will be in the infrared spectrum region. So this one is actually, you have to memorize lah which one is which. Okay, Lyman is UV, Balmer is visible, and this three is actually infrared. Okay, so based on the question just now, it mentioned that it is in the ultraviolet region. So ultraviolet region is actually our ultraviolet is Lyman series. So just first what we're going to write down is actually we have to know that this one means ultraviolet means that it is Lyman series. So ingat Lyman balik pasar beraputus, so it means that the ground state where the electron will fall will be n equal to 1. Okay, so from the line spectrum here, so here is what we call our line spectrum. So from our line spectrum here, first you have to know that where there's the biggest gap, itu akan jadi first line. So it's either on your right hand side ataupun your left hand side. Okay, but then bila kita tengok kan, this gap, this first and second line ni, gap dia is quite big. Kalau kita compare yang di hujung ni, very small. So we know that this line, is actually our first line. So I'm just going to write down here, it is my first line lah. So this is my first line. So if this is my first line, R will be my second line, Q will be my third line, P will be my fourth line, the one next to the P ni will be my fifth line, and so on. Okay, so again, we know that Lyman series is when the electron, dia akan fall, contohnya from here, from higher energy level, we will fall down to lower energy level. So maknanya dia akan drop to n equal to 1 lah. Okay, first possibility is when n equal to 2. Okay, so kita tulislah kat tepi ni. Kalau first possibility, kalau first line will be from n equal to 2 akan fall to n equal to 1. Kalau second line will be n equal to 3 akan fall to n equal to 1. The third one will be n equal to 4 will fall to n equal to 1. And the fourth line will be when n equal to 5 fall to n equal to 1. So dekat sini I'm just gonna go until the fourth line lah sebab yang P ni. Okay. So sekarang ni maksudnya this is actually this part, the second line is our R, the third line is our Q, and fourth line is my P. So if you want to write it down here pun boleh. So maknanya yang second ni is actually n equal to 3 fall to n equal to 1. So up to you lah nak tulis ke tidak. Dah tulis di tepi tu pun tak ada masalah. Okay, so question A is that calculate the energy corresponding to line Q. Okay, so kalau line Q ni is actually bila electron fall from n equal to 4 to n equal to 1. So bila dia fall barulah kita akan produce this energy. Okay, so maknanya from here, kalau Miss Padam dekat sini, maksud dia this is from n equal to 4 akan fall to n equal to 1. So delta E, we use the delta E RH initial minus final. Ada juga kita belajar delta E is equal to HC over lambda. Okay, H dengan C is constant, but we don't have any value of lambda, cannot use lah. The same goes delta E equal to H nu ataupun frekuensi kita. There's no frequency kan? So the delta E that we can use is only this one. Okay, so initial minus final lah. So maksud dia initial sebelum dia jatuh dengan dia jatuh. Okay, again initial tu must be a bigger value lah. Okay, maknanya dia jatuh sampai tingkat 2 ataupun dalam kes ni jatuh dari tingkat 4 dia jatuh tingkat 1. RH ada dua value kan. RH is actually dekat sini pun ada Miss dah terangkan. RH actually there's two value. 2.18 exponent negative 18 dengan 1.097 exponent 7. It depends. If you use delta E, ingat delta E ni because we're talking about joule. So kita kena guna RH yang involving joule jugalah, which is 2.18. If you're using 1 over lambda with length, this one kan with length. Maksudnya length kita, panjang kita is meter. So sebab tu dekat sini we use this RH 1.097 exponent 7 per meter. Okay. Okay, so back to the question. So tadi kita tahulah. So delta E initial minus final. We're talking about this one. The Q. So maknanya N equal to 4. To N tolak N equal to 4 to N equal to 1. So we will get this value will be negative 2.04 exponent negative 18 joule. Okay, negative ni means that energy is released. Okay, so that is for A. Okay, so next is for B. Dia minta dekat sini sketch the energy level diagram to show transition of electron that produce P, Q and R line. So kita dah tahu dah P tadi adalah fourth line when n equal to 5 turun n equal to 1. Q kita dah tahu third line when n equal to 4 turun n equal to 1. R kita tahu second line is when n equal to 3 turun ataupun will fall to n equal to 1. So we have written down. This one I believe kamu tiada masalah lah to determine the n tu. Okay. Okay, but right now they ask you to draw the energy level diagram. So what is actually an energy level diagram? So energy level diagram is based on this one. Yang ini Miss Datul yang this one. This is what we call energy level diagram. Where our y-axis is our energy. X-axis ni selalunya kita tak ada label lah. Okay, so for this one, selalunya kita akan start n equal to 1. Again, n must be a whole number. N cannot be equal to 0. Maksudnya first shell, n equal to 0. Mana ada shell 0? Okay, so back to the question again. Okay. So, kita akan start dengan n equal to 1. So, maknanya sini kita punya y-axis is energy. Okay, so first kita akan start paling bawah sekali adalah n equal to 1. Okay, so bila Miss calculate the value, this is the formula that we have calculated kan. The first ever formula that we have learned in this chapter 2 is En equal to RH1 over n squared. Okay, so when I substitute this value, okay, my value will become negative 218 exponent negative 20. Okay, so yang ni paling bawah dia sekali lah. Sebab dia negatif kan, negative 218. Okay, so next bila n equal to 1 kita dah tulis. Next is n equal to 2. So when n equal to 2, dia adalah negative 54.5. When I substitute the value, this will be it lah. Okay, so this is n equal to 2. So sekarang ni di sini it's just an extra explanation. Ni kamu tak perlu salin pun. Beza di sini sebenarnya adalah 163.5. Okay. Okay, lepas tu bila kita calculate when n equal to 3, kita masukkan dalam formula ni, we will get this one, negative 24.2 exponent negative 20. Sebenarnya bila kamu tekan dalam calculator, dia akan dapat negative 19 semualah. Tapi ni just Miss nak make it clear. So sebab tu Miss buat semua ni negative 20. Okay, so you will get this value. Lepas tu, bila kamu tengok, beza these two values between n equal to 3 dengan n equal to 2, beza dia adalah 30.3. So, maknanya dia, bila dari sekarang ni, dia punya beza makin kecil. So, what will happen is actually, n kita ni kena makin lama makin dekat lah. Sebab ni dah beza dia 163. Ini beza dia 30. Okay, so makin lama kena makin dekat. So, when n equal to 4, Miss masukkan dalam this formula, I will get this value. So, the difference between these two value pula adalah 10.6. Kan makin kecil. So, that's why makin lama kita tengok, n ni makin lama makin dekat. Kalau kita tengok lagi kan, sebenarnya nanti boleh dekat macam ni lagi, betul-betul dekat, betul-betul dekat. Okay? When n equal to 5, we get this value. So, bila Miss bezakan dua ni, when I count the difference, here the difference is actually 4.88. Okay, so now you get the idea where when n equal to, when the higher the n, maksudnya the difference between contohnya n2 dengan n1 ni besar kan, makin lama the difference tu makin kecil, makin kecil, makin kecil. Sebab tu line dia makin lama makin dekat, makin dekat, makin dekat. Kamu tidak boleh lah buat dia sama sahaja. Cannot. Macam ni, sama sahaja dia punya beza tu cannot lah. Kena make sure dia makin lama makin kecil ataupun makin lama makin dekat. Okay? So, tapi again, in your notes, tak perlulah nak tulis value ni. Ini Miss nak tunjukkan. Kamu pelik kenapa dia makin lama makin dekat, Miss? Sebenarnya sebab bila kita tekan value dia, bila kita plot graf tu, kita akan dapat line tu makin lama makin kecil lah. Okay? Tapi yang ini Miss nak clearkan je lah. Sebenarnya, kamu tak perlu tulis pun semua value ni. Okay? So, kat sini Miss akan padam balik semua. Okay, so yang itu yang paling penting kamu kena ingat. Dia makin lama line tu makin kecil. Sebab bila kita masukkan n tu dalam formula kita dapat value dia. Makin lama dia makin, the difference is getting smaller. Okay, so maknanya this is it. Yang ini yang memang kamu kena ingatlah how to draw. Okay. So, macam mana daripada kita punya line spectrum ni nak tukar jadi line diagram, energy level diagram. Okay, so sekarang dia minta show the transition of electron that produce P, Q and R line. Okay, so sekarang ni kita dah tahu tadi P ni adalah bila from n equal to 5 to n equal to 1. Selalunya kita tulis macam ni sahaja kan di soalan-soalan kita. Sekarang ni kita kena draw lah. So, kalau kita start, ikutlah mana nak start. PQR ke RQP, mana-mana boleh. Okay, start dengan R lah. Contohnya, R ni second line is n equal to 3 to n equal to 1. So, tengoklah di sini. N equal to 3, turun jadi n equal to 1. Kamu nak start mana-mana boleh. Kanan boleh, kiri pun boleh. So, contohnya, Miss start dekat sini. So, dekat sinilah. So, jangan lupa label. From n equal to 3 to n equal to 1 is actually my R. So, label lah. This is my R. Okay, next adalah my Q line. When n equal to 4, turun to n equal to 1. So, tulislah. Pada n equal to 4, jadi n equal to 1. Okay, so this is my Q. Last but not least is my P. P adalah bila n equal to 5 jadi n equal to 1. So, n equal to 5 turun jadi n equal to 1. Okay. So, this is it. Okay. So, selama ni kita hanya tulis sahaja kan. Sekarang ni kita kena draw pula. So, maknanya first and foremost kamu kena make sure lah. Okay. Dekat sini kena tahu mana satu first line kita. Which one is my first line. Lepas tu labelkan second, third, fourth, fifth. Lepas tu barulah kita buat yang mana lah. Ingat, which one is our ground state. Okay. So, contohnya, if I took this one yang my first line ni as, contohnya Miss tulis ni A. Okay. So, maknanya sini first line ni is my A. So, kalau dia minta kita lukis A, A maksudnya from n equal to 2 jadi n equal to 1. So, n equal to 2, jadilah n equal to 1. Contohnya kat sini Miss tambah sendirilah. Okay, this is my A. Okay, so that is actually macam mana once the electron fall from the higher energy level to lower energy level, itu yang kita boleh form kita punya line spectrum. Okay, so next kita tengok macam mana pula kalau ada soalan dia bagi line spectrum, dia minta transition. Okay, so contohnya ni soalan pada Google Form. Okay, state the transition of line S in the alignment series. So this is line S. Again, before anything, which one is our determine dulu first line kita. First line mesti sama ada dia boleh jadi yang paling kiri atau paling kanan. Tengok yang mana paling besar dia punya gap. Okay, this one kan besar gap dia ni. Ni yang ni kecil je. So this is my first line. This is my first line. Okay, so kalau this is my first line, so this is my second, this is my third, this is my fourth, this is my fifth. Okay, state the transition of line S in alignment series. Alignment series maknanya, maksud dia Sn equal to 1. Okay, so if S, so S will be n equal to 2 will fall to n equal to 1. Okay, so contohnya kalau Miss nak draw in terms of energy level diagram, so dia akan jadi di sini it will become from n equal to 2 jadi n equal to 1 ni jadi S. Okay, kalau yang T ni, for my T is when n equal to 3 akan fall to n equal to 1. So again, from n equal to 3 to n equal to 1. Okay, kalau yang U ni is my third line when n equal to 4 to n equal to 1. So kita draw lah from n equal to 4 to n equal to 1. Okay, so this is my U. Okay, so hopefully you get the idea. Okay. So dekat sini, from the example from the Google Form as well, okay, state transition of line T in bracket series. Bracket series memang balik pasal bra. So n equal to 4. Maksudnya akan fall to n equal to 4. Okay, so kita tahu tadi sini kita dah write down this is my first, this is my second, this is my third, and so on. So, kalau n equal to 4, first possibility adalah when n equal to 5 tu akan turun, n equal to 5 will fall to n equal to 4. So, pada energy level diagram ni, from n equal to 5 turun n equal to 4. So, this is my S. Okay, next possibility is T second line, n equal to 6 akan fall to n equal to 4. So, kita lukislah sini. Sini kita punya T from n equal to 6 to n equal to 4. So, this is my T. So, contohnya kita buat lagi dekat lagi line kita ni kan. Okay. Okay, so contohnya this is my n equal to 7. Yang paling atas ni n equal to 7. Okay, so kat sini third line kita tahu kan n equal to 7 to n equal to 4. Okay, so maknanya 7 ni turun dekat 4. So ni adalah U kita lah. Okay, so sebenarnya kita punya this is what we call our line spectrum ni. Our line spectrum dengan energy level diagram ni, dia sebenarnya related to each other lah. Okay, bila setiap elektron ni fall, contohnya daripada sini fall, barulah dia boleh form this one. Okay, bila n equal to 6 turun pada n equal to 4, barulah form yang line T ni. Bila elektron fall from n equal to 7 to n equal to 4, barulah dia boleh form line U ni. Okay, so that is your energy level diagram. Okay, so if you think this video is a bit too long, actually kamu boleh turn the speed to 1.75 lah. Takut kamu terlepas yang mana-mana. Okay, so that's it for this video.